In this video, I'm going to show you how to use the calculator to obtain confidence intervals for a population mean using the t-distribution. I'll be taking a problem from section 9.2 here. It's taken from pages 484 and 485 in the text, in particular problem number 22. Now you can see that there are two data sets associated with that problem, and I've already got them keyed in to list 1 and list 2 respectively, just to save some time. One of the most common things that people struggle with as they go through chapter 9 is distinguishing between when it's appropriate to use a z interval and when it's appropriate to use a t interval. Of course, the z interval is a confidence interval that's based on the normal distribution, and a t interval is a confidence interval that's based on the student's t distribution. And the orthodox party line on that is that when you don't know the population standard deviation, then you use a t distribution. Now, it is true that as the number of, or as the sample size increases, in other words, the number of degrees of freedom in the t-distribution, as that increases, the t-distribution effectively approaches the normal. And so, in fact, if you were to take a t-distribution with a given standard deviation and a given mean and a sample size of, say, 30, so you have a certain number of degrees of freedom, and you were to compare that with a normal distribution with the same mean and standard deviation, you'd find that they coincide very, very closely. But nevertheless, bottom line is, if you don't know the population standard deviation, then you ought to be using the t-distribution. So for the problem that we're going to do here, number 22, it says as follows: PepsiCo stock volume. The trade volume of a stock is the number of shares traded on a given day. The following data in millions, so that 6.16 represents 6.16 million shares traded, represent the volume of PepsiCo stock traded for a random sample of 40 trading days in 2007. Part A is asking, use the data to compute a point estimate for the population mean number of shares traded per day in 2007. Well, they're referring to the data that's in list 1 here, and probably the easiest way to get that would just be to run the one variable stats on list 1. Remember that function there, one var stats, it defaults to list 1, so you just have to press enter and you'll have it right there. So your point estimate would be x bar, and that's 5.423. So in other words, 5.4 million and some change would be the point estimate. Part B is asking, construct a 95% confidence interval for the population mean number of shares traded per day in 2007. Interpret the confidence interval. Now put yourself in the shoes of someone taking an exam for just a second here and think about this. What about this problem would tip you off that a t-distribution is called for? Well, when you scan the problem, there is no mention of sigma, which is population standard deviation, given anywhere. And so that tells you, well, I don't know sigma, and that means I would be using a t-distribution. So to create this confidence interval, we go to the stat menu, and we go to the test menu, and it's function number 8 that we're looking for here. Let's scroll down. I just went past it right there. You can see it there. It's a t-interval, right? So that's a confidence interval that's based on the t-distribution. I went too far. To get access, you can press number 8. And we're doing a data-driven problem here, so all we have to do is tell it where to look. And in this case, we want it to look in list 1. That's correct. The frequency is 1. It should always be. Don't ever change that. And the confidence level would be 95%. So let me change that to 0.95. And we're ready to calculate. And there is our interval right there. They ask us to interpret the confidence interval. Well, what we can say is that we are 95% confident that the true mean number of shares for Pepsi in 2007 is contained in that interval right there, between 4.95 and 5.89. So in other words, if we were to take 100 random samples of Pepsi volume and we were to compute confidence intervals for all of them, we would find that on the average, about 95 of them would contain the true mean, supposing we knew it, and 5 would not. That's what you've seen in the Java applet there that does confidence intervals for you. But we prefer the other interpretation that I gave, in other words, that we are 95% confident that the true mean is contained in this interval here. Part C says a second random sample of 40 days in 2007 resulted in the following data. Now I have that one stashed in list 2, and they want us to do another 95% confidence interval for that. Now look carefully. This interval goes from 4.95 to 5.89. Let's see what the other one does. everything the same except we want to be looking in list 2. That's where the data is stashed. So we can calculate, and there the interval is right there. Now they're asking us in part D here, explain why, or well, they want us to interpret that interval as well. So if we interpret it, we'd say, well, we're 95% confident that the true mean volume of Pepsi shares is between 5.298 million and 6.321 million, or words to that effect. And then part D is asking, explain why the confidence intervals obtained in part B and C are different. Well, they were based on different samples. Why would you expect them to be the same? Of course they should be different because they were based on different samples. Anyway, that is a t-distribution, and the one thing you should take away from this video here again is, how do I know when I'm supposed to use the t-interval as opposed to a z-interval? Use the t-interval when you don't know the population standard deviation. Hope that helps. In the next video we have a couple more examples for you.